Hi, this is Mr. Warden. I'm going to be talking about the standard form. So we've done, at this point, you've probably done the slope-intercept form, level 5A. You've probably worked with the point-slope form, which is 5B. That's where you have a point and a slope, and you can come up with a line equation for that. You probably worked with the intercept form, and the intercept form is where you have the x and y intercepts. X over the x-intercept plus y over the y-intercept equals 1. We're going to talk about the standard form. And the standard form is a little more general in its structure. Its main use for us is going to be a couple things. One is that it gives us easy ways to find the x and y intercepts. And if you have 2 points, you can plot them and draw a line through them. So it makes it easy to graph a line. A second thing is the standard form is going to show up a lot in the next unit, which is on systems of equations, where you're trying to figure out where 2 different linear equations intersect with each other. And the standard form is going to play a big role there. And the third reason is the standard form is very useful for situations where you might have 2 different rates, like 2 different speeds that you've gone on a trip, or 2 different prices per pound, or 2 different percentage rates. And as you probably have figured out, rates have something to do with slope, but what if you had 2 different rates? That's not quite the same as a slope, but 2 different rates can be worked with a standard form. But let's just, I'm going to give you the basics of it. The standard form is this. It's in the form ax plus by equals c, where a, b, and c are all what are called coefficients. And this is introducing some new language. A coefficient is a multiplier. It's generally a number that is a multiplier of variables. So if I say 5x, the coefficient of that is 5. The variable is x. So 5x, if I use the slope-intercept form, y equals mx plus b, the coefficient of x is the slope. It's m. It's the number that is times x. A coefficient can also be a standalone constant. So this c is just a number. All right. So I'm going to bounce down to the section. As you probably know, you can click on these and go down to the proper bookmark, and there it is, the standard form. Now, the standard form, once again, it's a form where we have ax plus by equals c, and a, b, and c are coefficients. Generally speaking, we say that a, b, and c have to be integers. A is supposed to be positive, and a and b you can't have both a and b be equal to 0 for it to formally be standard form. I will let you know that if you don't have them being integers, if they're fractions, or if a is negative, you'll still be able to work with it just fine. But the formal definition is that a has to be a positive integer, or should I say a non-negative integer. A and b and c all have to be integers for it to formally be standard form, and you can't have both a and b equaling 0. All right, but let's talk about how it works. So I think the easiest way to do that is to go into a Desmos. You should read this stuff because it has the same kind of information that I'm going to talk about. The standard form is easy to graph because you can find the x and y intercepts, because you can always, if the x-intercept is where y is 0, you don't need to pay any attention to this by term because y will be 0 and by will be nothing. So you just have ax equals whatever c is. So x will be c over a. So right here would be the x-intercept. And I'm going to demonstrate this for you in Desmos. The y-intercept, of course, will be where x is 0. So you'll ignore the ax term, and you'll just have by equals c. So y would be whatever c is over whatever b is. So your y-intercept, this gives you a cheat code for the y-intercept. And then you can find the slope. The slope will be negative a over b. So let's go into Desmos and talk about this stuff. So you'll probably recognize this is not a standard form equation. I'm going to go through the process of rearranging it into a standard form equation, though. The first thing I'll do is I will get x and y on the same side by subtracting y from both sides, and I'll get the number on the other side by adding 12 to both sides. So I'll add 12 to both sides, and I will subtract y from both sides. Copy pasta that, and let's clean it up. Negative 12 plus 12 is nothing, and y minus y is nothing. So, and then I'm going to switch sides. I'm going to move this over here because equal signs means symmetry. We are symmetrical when we have an equation. And now I've got 3/2 x minus y equals 12. And now what I want to do is I want to get rid of this denominator. And to get rid of that denominator, I'll multiply that times 2. I'll multiply that times 2. And I'll multiply that times 2. So everything got doubled. We'll copy pasta that. And this becomes 24. And this 3/2 times 2 is just 3. So 3x minus 2y equals 24. Now we have an equation that's in standard form, and it's graphed over here on the right. You can see it. Make those go away so we don't get distracted by them. But how would we find the x-intercept? So to find the x-intercept, we take this. And if you remember, if you know you've got an x-intercept, then you know the y value. The y value is going to be 0 on the x-axis everywhere. So you can just replace y with 0. And you'll see it makes a vertical line. That's just saying that x is all of these. X is one particular value for an infinite number of points on a vertical line. Now, since I made y 0, I don't care about minus 2 times 0 because that's just 0. So I'm just 3x equals 24. And that, I just divide both sides by 3, and x will be 8. So 8 is my x-intercept, and I click on there. You can see 8, 0 is the x-intercept point. Now, what about the y-intercept? The y-intercept, okay, let me actually finish this up. So that's divided by 3 and divided by 3. Okay, so you might notice that my x-intercept ends up being this c coefficient divided by the a coefficient. So 3 is a, b is negative 2, and c is 24. Okay, so there you have the x-intercept. Now let's find the y-intercept. To find the y-intercept, we just replace x with 0. Okay, and you notice it makes a horizontal line. That means I've got a y value, and the y value happens to be at negative 12. But let's go through the process of solving that. So we don't care about 3 times 0 because that's just 0, and we're left with just 2y equals 24. And then we can divide both sides by negative 2. So y equals 24 divided by negative 2. We'll look at that. That's the c coefficient divided by the b coefficient. Okay, and that ends up equaling negative 12. And you can see right here, the y-intercept is at 0, negative 12. And we can find the slope from these 2 points, of course. We've got these 2 points. We got a point at negative 0, negative 12, and 8, 0. Well, the rise, if I did a rise here from this point up, and then a run here, the rise from negative 12 to 0 is just going to be 12. That's plus 12. And the run from 0 to 8 is plus 8. So our rise over run is 12 over 8, which we can simplify as 3 over 2. Now, 3 over 2, we have this equation that's 3x minus 2y equals 24. Now, where were we seeing a 3 and a 2 in our equation? Oh, there's a 3 here, and there's a negative 2 here. So it turns out that the slope for a standard form equation is going to be, you're going to take your a term over your b term, which is negative 2 in this case, and then you're going to get the negative of that. And that'll be slope. The x-intercept is always going to be your c coefficient over your a coefficient. That'll always be your x-intercept. And your y-intercept will always be your c coefficient over your b coefficient. And it's helpful that these are both b's and these are both a's. That's a lowercase a we use for the x-intercept, a lowercase b we tend to use for the y-intercept. But this is a cheat code for you with the standard form. All right. I'm going to say just a couple more things. So I mentioned earlier that standard form is really useful for working out modeling situations where you have two rates. So I'm going to give us an example of that. I'm leaving this here so hopefully you can write it down. I'm going to create a situation with two rates. Okay, you buy $50 worth of dog food. Okay, you get fancy dog food, which is, say it's 14. We'll make that, it's going to be $15 per pound. And cheapo dog food, which is $2 per pound. Okay, so you know that you have spent $50 overall, but you don't remember how many pounds of each you got. Well, we can model all the different possible combinations it could have been. Now, the number of pounds will always be a non-negative number, so you would end up restricting your domain and range for this, but let's just start off by modeling it. So this $50 is based on price per pound times the number of pounds for the fancy dog food plus price per pound times number of pounds for the cheap dog food. So we can say, okay, X is pounds. We're going to have two variables here. The number, we don't know how many pounds of fancy. And let's say Y equals pounds of cheapo. Okay, so let's create an equation. So $15 per pound times the number of pounds of fancy plus $2 per pound times the number of pounds of cheapo is going to equal $50. And that creates an equation. Let me now erase all the stuff that's up here because it's going to get distracting. So you see that thin blue line that's just formed? That is going to be a graph of the possible arrangements, possible combinations of cheapo dog food and fancy dog food that you bought. Okay, I'm going to turn these earlier ones off to remove distractions. Okay, so now we've got this line. Now, we're not going to have any negative amounts of pounds of cheapo or any negative amounts of pounds of fancy. So I'm going to make a restriction. So I use the fancy brackets. I'm going to say X is greater than or equal to 0. So because fancy could be 0. You could have bought none. And then I'll make another one. Y is greater than or equal to 0 as well. So that restricts it to only non-negative values. I'll zoom out a little bit. So here you have all the possible combinations. You could have bought 2.9 pounds of fancy and 3.25 pounds of cheapo. You could have bought, well, let's get down to 1 pound. 1 pound of fancy and 17.5 pounds of cheapo. So this actually gives you a way to model all the infinite possible combinations of dog food that you could got. You could have gotten 0 pounds of fancy and 25 pounds of cheapo. You could have gotten 3 1/3 pounds of fancy and no pounds of cheapo, and all sorts of combinations in between. So all those XY points represent the number of pounds of fancy for the X term and the number of pounds of cheapo for the Y value. Okay, so X value is fancy pounds, Y value is cheapo pounds. And this would allow you to go ahead and figure out, if you could pin down how many pounds of fancy, you could then solve for Y, because you could just plug in a value for X and then you'll have one variable. Okay, so this models, and in the next unit, we'll be working with some of those models. But in this unit, I just need you to be able to create some equations for that. I'll do one more here. This will be an investment one. Okay, so in this case, you put some money in one bank. And are earning 5% interest per year. Okay, and you put some money in another bank and are earning 7%. These are really high percents, by the way. Banks never give you this sort of amount per year, unless you're investing enormous amounts of money. Okay, at the end of the year, the interest you have earned is worth $200. Woo, $200. Okay, so here's what we've got. We've got two amounts of money. We don't know what they were. You just know that after a year, 5% of it, of one of the amounts, and 7% of the other amount added up to $200. So we can actually use those numbers to set up an equation. If we say X is the money invested at 5% and Y is the money invested at 7%, we can create a model. Okay, and here's the model. So it's going to be 0.05x, because that's the amount. 0.05 times however much money you put in the first account, plus 0.07, notice these are both rates, times Y. We add those two things up and you get $200. Now, as you probably noticed, these are not in standard form. I have to zoom out to get to the graph of this, I believe. There it is. So this will actually give you, if you have invested $0 in the 5% account, that's the X value, you would have had to invest $2,857 and about 14 cents in the 7% account. On the other hand, if you had invested $0 in the 7% account, X, the 5% account money, would have to be $4,000 for you to get to this $200. And then there's all these combinations that you could have done. So if you've ever wondered, what are the real world applications? Well, in fact, here's one where you could be doing some financial planning about how you would arrange money to get to $200 at the end of a year. Probably you'd be needing to get more than 200, but maybe you're just trying to raise money to buy something small. So $1,300 in the 5% account, about $1,928.57 in the 7% account would get you to where you need to be. Okay, now this is obviously not in standard form, so I'm going to put it in standard form by scaling all parts up by 100. I need to move these decimals over by 2. And if you remember clearing the decimals way back in equations, clearing the decimals, if I multiply every part of this by 100, I get rid of the decimals. I end up with 5x plus 7y equals 200 times 100 is 20,000. And that's the equation. And of course, this equation, you're not investing negative amounts, so we're going to say x is greater than or equal to 0, and y is greater than or equal to 0. So we have this situation where we have two different rates, and the products of those rates and some unknown amount of money, if you add those two products, you'll get the result, the sort of sum of those products. And if you have that sort of situation, a standard form is a really good tool for you. All right, I'm going to stop because this is kind of a long video, and I hope this is helpful.